All right, let's dive into a really cool puzzle from the world of machine learning. Think of it as a showdown, a battle between four different models. Our job is to figure out which one is the most powerful. But here's the twist. They're all competing in a very, very simple universe. So here's the setup. We've got four models, H1, H2, H3, and H4, and their entire world, their whole playing field, consists of just four little data points. The big question is, which one's going to come out on top? Are any of these secretly the same? And is one of them just fundamentally better than the rest? Here's how we're going to crack this thing. First, we'll lay out the puzzle itself. Then we'll pit lines against circles to see who wins. We'll explore why just mashing them together with an OR doesn't help. And then we'll uncover the one simple trick that changes everything. And finally, we'll put it all together to see how they all relate. Okay, let's get into it. Before we can judge our models, we have to understand the world they live in. Now, it's technically called the 0-1 squared space. Sounds a little fancy, right? But trust me, it's about as simple as it gets. Yep, that's it. Our entire universe is just these 4 points sitting at the corners of a square. The whole game for our models is to find a way to separate these points, to draw some kind of boundary that groups some of them together and leaves the others out.
So let's bring our first two competitors into the ring. In one corner, we have the simple, classic straight line. And in the other, we have the elegant, flexible circle. In our tiny 4-point world, how do you think they're going to stack up against each other?
First up is model H1, the linear model. Its strategy is really straightforward. It just draws a single straight line. Anything on one side of the line is in one group, and everything on the other side is in another. It's one of the most basic building blocks in all of machine learning. And now it's time for the classic boss battle for any classification model, the XOR problem. The challenge is simple. Can you group the two diagonal corners together and separate them from the other two? Can a single straight line pull it off? And the answer is a big, fat no. Just try to picture it. No matter which way you slice that square with one straight line, there is absolutely no way to get those two diagonal points on one side and the other two on the other. It's impossible. So, big takeaway, H1 fails the XOR test. All right, so the line is down for the count. Let's bring in the next challenger, model H2, the circle model. Its move is to draw a circle. Points inside get one label, points outside get another. You'd think this would be more powerful, more flexible, right? Well, here's the twist. In this tiny 4-point world, that extra flexibility is just an illusion. Think about it. A circle can loop around 1 point, or 2 points that are next to each other, but it can't draw a clean boundary around 2 points on the diagonal without catching one of the others. And it turns out, a simple learn can make every single one of the exact same groupings. So even though it looks fancier, the circle has no extra power here. And that means, just like the line, H2 also fails the XOR test. So let's just put them side by side. The linear model uses a line. The circle model uses a circle. But in terms of what they can actually do in our little world, they are exactly the same. They can solve the same simple problems, and they both fail the big one, the XR problem. And that leads us to our first major discovery of the day. Despite their completely different shapes, when it comes to actual problem-solving power in this space, H1 and H2 are identical. They're equals. Okay, so if one model on its own can't get the job done, what if we team them up? Let's check out a model that combines H1 and H2. Is this going to give us the superpower we need? So, say hello to model H4, the union model. The logic here is really simple. A point is considered positive if the line model or the circle model says it's positive. We're basically just taking all the possible solutions from both models and lumping them together. But, and you probably see where this is going, there's a huge catch. We just proved that H1 and H2 are exactly the same. They have the exact same set of solutions. So combining two identical toolboxes doesn't give you any new tools. You just have two of everything you already had. And this leads us to our second big conclusion. This union model, H4, is no better than the models it was made from. So now the leaderboard shows a three-way tie. H1, H2, and H4 are all stuck at the same power level, and none of them can solve our puzzle. So the OR logic was a bust. But what if we tried a different kind of logic? This, my friends, is where we get our big aha moment. Let's welcome our final competitor, Model H3, the intersection model. Its secret weapon is just one little word, and. Instead of or, it says a point is positive only if a first model and a second model both agree. This simple change is a total game changer. So how does this AND logic actually crack the XOR problem? Well, it's pretty brilliant. It uses two simple lines to create a complex shape. In step 1, you can use a line to create a region. Then, in step 2, you use a second line to create another overlapping region. The magic happens in step 3. H3 says the solution is only the area where those two regions intersect, the part that satisfies the first rule and the second rule. And by carefully placing two lines, you can carve out a corner-shaped region that perfectly grabs those two diagonal points and nothing else. It's the first model that can actually do it.
Okay, the dust has settled. We've seen all 4 models in action. We know who failed and who succeeded. So now it's time to put it all together and declare the final, ultimate relationship between them.
I mean, this chart says it all, doesn't it? H1, the line, H2, the circle, and H4, their OR combination, they all hit the same wall. They just didn't have the complexity to solve XOR. But H3, the intersection model with its powerful AND logic, yeah, it sailed right through. It's in a totally different league. And that gives us the definitive answer to our whole puzzle. H1, H2, and H4 are all completely equivalent in their power. And all 3 of them are just a small piece of what the much more powerful H3 can do. H3 can do everything they can do, and a whole lot more. So if you remember just one thing today, make it this. The real power in machine learning often comes from combining lots of simple rules in clever ways. That little and let us build something that was way more powerful than the individual pieces we started with. And that leaves us with a pretty mind-blowing final thought. We just saw how combining 2 simple lines could solve a problem that one line couldn't even touch. So what happens when you combine not 2, but thousands or millions of these simple boundaries, all layered together? Well, you get the basic idea behind a neural network. You get the foundation of modern AI.